Alright everybody, it's Mr. Yosef. We're going to get through this inverse circuit as quick as we can. Also, just forget, before you start, you should know about how arc sine, arc cosine, and arc tangent. You should know the graphs and the restrictions. If you don't know that, I'll kind of mention it throughout the video, but just keep in mind that those will be really helpful. So this first question, we're doing sine inverse of negative square root of 2 over 2. So just keep in mind that when you're doing the inverse of a ratio, we're looking for an angle. And from your notes, you should know that sine inverse is restricted in quadrant 1 and quadrant 4. Since this value right here is negative, we know that we're going to be in quadrant 4. So now what you're thinking about is, at what angle do I get a square root of 2 over 2? So if we look at our unit circle, we're in our fourth quadrant, we should know that at negative pi over 4, you should have square root of 2 over 2 and square root of 2 over 2, and the y value should be negative. So a lot of you are saying, where do you get negative pi over 4? Negative pi over 4 is the same thing as 7 pi over 4. So if you think about pi over 4 being here, negative pi over 4 is the same thing as pi over 4, but you're just going clockwise. So instead of saying 7 pi over 4, we're just going to say negative pi over 4. So sine is our y value. So at what y value do we get negative square root of 2 over 2? The answer to that is going to be negative pi over 4. So we're going to go down and we'll find that, and that's right here. So now we're doing arc cosine of a half. Once again, arc cosine is another way of saying cosine inverse of a half. Both of these are equivalent. So from your notes, we need to know that cosine inverse is restricted in quadrant 1 and quadrant 2. Since we have a positive value of a half, we know we're going to be in quadrant 1. So now you have to ask yourself, if I'm in quadrant 1, which value has a x value of a half? Was it 30 or 60? So when I think about this, 30 is right here. So I know opposite to 30 is a half. So I know it looks like this. And 60 is 1/2 square root of 3 over 2. So which one is cosine or x value a half? That is going to be 60. So the answer to this is pi over 3. So let's go find pi over 3, which will be right over here. So we're at number 3. So now what we have is called a composition of function. So you start inside and then you work your way out. So when I'm looking inside and I see tangent of pi over 4, this is a regular trigonometric problem that I've been exposed to in the past. If I put in an angle, I should get a ratio. So if I'm doing tangent of pi over 4, at pi over 4, you should have square root of 2 over 2 and square root of 2 over 2. The definition of tangent is y over x. This is my y, this is my x. So if I do square root of 2 over 2 divided by square root of 2 over 2, tangent of pi over 4 is 1. Now I'm doing a problem where I'm solving for tangent inverse of 1. So this means that I'm looking for an angle. So I have to ask myself, tangent inverse is restricted to quadrant 1 and quadrant 4. Once again, my angle is positive. So does everybody see that the answer to this is actually pi over 4, because square root of 2 over 2 divided by square root of 2 over 2 gives me 1. So on this problem, you actually ended up back to where you started, and we get pi over 4. So if we look for pi over 4, that's going to be right here. So as you go through the video, I'll be picking up the pace a little bit, but feel free to message me with questions or even leave comments. So now we're doing the inside once again, which is right here. Oops, we don't want that. All right. So this question is asking, what angle gives negative 1/2 for cosine? So remember, cosine is restricted in quadrant 1 and quadrant 2. So if we have a negative value, that means that it's going to be in quadrant 2. And where is my x value? A negative half. So I believe if we think about that, opposite of 60, so I think my 60 angle is 2 pi over 3. This point should be square root of 3 over 2 comma negative half. So if I'm doing cosine, that means it should be my x value. So the answer to this is tangent of 2 pi over 3. I want us to notice that 2 pi over 3 is in the second quadrant. Our x values are negative, and it meets the requirement of being in either quadrant 1 or 2 based on our restrictions. Now we're solving for tangent of 2 pi over 3. So the definition of tangent is y over x. So now I'm going to do square root of 3 over 2 divided by half. And if I multiply by the reciprocal, I get negative square root of 3. So let's see if that is one of our answer choices. Right here. So now we're on 5. Once again, I'm doing arc sine of a half. That means either quadrant 1 or quadrant 4. Since sine is a half and positive, that means at 30 degrees, everybody, you should know that it's square root of 3 over 2 comma half. So now it's cosine of 30 or pi over 6. And then cosine of pi over 6 is our x value, which is going to be square root of 3 over 2. So as you keep going, you get quicker. So now we're going to find square root of 3 over 2. All right, and now we're here. So now it gets a little bit more interesting. So now it's tangent, arc tangent of 0. So what degree gives me 0? So we think of our unit circle. Once again, tangent is restricted in quadrant 1 and quadrant 4. Sometimes it's helpful to just write these angles because I feel like sometimes we just mix them up. And you have to ask yourself, tangent means y over x. So if I want to have 0, I hope we see that the only answer is 0. Because if this is x and this is y, and tangent means y over x, then arc tangent of 0 is actually just 0. And then sine of 0, which is what is my y value when my degree is 0, is also 0. So you get an answer of 0. I think I just said 0 so many times, but I hope we get it. Now we move on to 7. Once again, I'm starting inside. So if I start inside, tangent of 3 pi over 4, this is a regular problem that I've done in the past. I'm plugging in an angle, or in this case, a radian, and I'm going to get a ratio. So at 3 pi over 4, that should be in the second quadrant. And it should be negative square root of 2 over 2, comma square root of 2 over 2. So that means that if I divide y over x, you just get negative 1. And then cosine inverse of negative 1 is quadrant 1 or quadrant 2. Once again, I know it's in quadrant 2 because I got a negative answer. And if you're at pi, everybody, I hope you remember that this is negative 1 comma 0. And the definition of cosine is the x value. So at what x value, at what degree will give me an x value of negative 1? This answer is pi. So we're right here. I hope it's starting to feel a little repetitive. So next is cosine of negative 4 pi over 3. So once again, I'm just answering a question of what's the ratio when given this radian measure. In my head, if I have negative 4 pi over 3, that means if I add 6 pi over 3, that's actually going to tell me the equivalent in a positive form, which is 2 pi over 3. And the reason why I did 6 pi over 3, everybody, is because I'm just adding 2 pi. So negative pi over 3 is just going this way. Right there. But I hope that we see that we end up at 2 pi over 3, which is negative 1/2, comma, square root of 3 over 2. The question asks for cosine, so that's my x value. So I have sine inverse of negative half. I know sine inverse is quadrant 1 or quadrant 4. Once again, if I look at quadrant 4 and look at negative pi over 6, you should see, square root of 3 over 2, comma, negative half. So this answer is just negative pi over 6. All right, where is that? Leads us right here. All right, next question, let's do tangent of negative pi over 4. So if it's negative pi over 4, that means I'm going clockwise from 0. So negative pi over 4 is right here. And our x value is positive, and our y value is negative. So if I divide those, I'm going to get sine inverse of negative 1. So now if sine inverse is quadrant 1 and quadrant 2, and I have a y value of negative 1, I hope that we know that at negative pi over 2, the point is 0, comma, negative 1. And our y value, negative 1, is right there. So the answer to this is negative pi over 2, which is our final answer. Right here. All right, so next let's make this a little bigger. Let's do cosine of 11 pi over 4. So if I draw this, 11 pi over 4 is interesting because I feel like that's more times than 2 pi. So 2 pi, everybody, is the same thing as 8 pi over 4. So I know when I see 11 pi over 4, that means I went over. So if I do 11 pi over 4 minus 8 pi over 4, that takes you to 3 pi over 4. So if we were going to draw this, you would go around once and then go here. But I hope we see that the reference angle is 45. But it doesn't matter. If you know you're at 3 pi over 4, you can just use the unit circle. So this is going to be negative square root of 2 over 2, comma, square root of 2 over 2. So the question asks cosine, so that's going to be our x value. So we end up with arc cosine of negative square root of 2 over 2. And now the question is, at what angle or what radian measure gives you negative square root of 2 over 2? Cosine is restricted in quadrant 1 and quadrant 2. So it's actually going to be this value, everybody, 3 pi over 4, because that's where our x value is negative, and that's the radiant measure in the second quadrant. So you end up getting 3 pi over 4. And I think I forgot to number this one, which is not good because I'm probably going to forget. I think this one was 10. So we're looking for 3 pi over 4, which should be 11 right here. All right, this next one is pretty tricky. So this one says cosecant inverse of 2. So you have to remember that cosecant, everybody, is the reciprocal of sine. So that means that everything is being flipped. So instead of thinking about cosecant inverse of 2, you should think about sine inverse of a half. And I know this might seem strange, but let's think about it. Cosecant is the reciprocal of sine. So if I figure out which angle gives me a half, I know that if I flip that ratio of 1 over 2, that would be 2, and that would be associated with cosecant. So to answer this question, what is sine inverse of a half? Once again, quadrant 1, quadrant 4, oops. What angle gives me a half? I hope we see that it's pi over 6. So if I do sine of pi over 6, that's going to give me 1 over 2. If I do cosecant of pi over 6, isn't that just going to be the reciprocal of whatever answer I got here, which would be 2. So that's why this answer works. And instead of looking at this, you could always just flip this inside part, which is this 2, flip it, and think of the reciprocal instead of thinking about cosecant. And you'll see there's going to be another example where we do that same thing right now. So let me find that example, and hopefully it makes more sense. That example is right. It's 12. I think we might have one more problem until we run into something like that, but just keep that in mind. So next we have 12, which is cosine inverse of -1. I think we already answered this one earlier. Cosine inverse is Q1, Q2. At pi, it's -1 comma 0. So now we got cotangent of pi. The definition of cotangent, I'm going to write this one down, is x over y. So if you're at pi and you're doing x over y, that would be -1 over 0, which is undefined. So the answer to this is undefined, which is right here. And this is probably going to be one of the hardest examples right here, and goes back to the example before the one we just did. So you have secant inverse of 2 square root of 3 over 3. So instead of doing secant, I would do cosine inverse, and I would actually flip this one. And the funny part is if you flip it and you rationalize it, you're going to get a really interesting result. Also, I hope everybody sees that square root of 3 times square root of 3 on the bottom is just 3. So you get 3 square root of 3 over 6. And do you see how you just get cosine inverse of square root of 3 over 2? So we can actually just solve this, which is going to be the same answer as what's highlighted in purple. So cosine inverse of square root of 3 over 2, well, if we think of the unit circle and look at 30 degrees, 30 degrees is square root of 3 over 2 comma 1/2. And cosine inverse of square root of 3 over 2, that's our x value. So this equals pi over 6, or 30 degrees. And then we're going to do tangent of pi over 6, which is y divided by x. And you get 1 over square root of 3. And then rationalize this. And your final answer is square root of 3 over 3. That one was fun. And you started picking it up. It just takes time and practice. So let's get to 14. So let's do this one right here. So once again, I'm doing arc sine. So Q1, Q4. Do you see how I just keep writing it over and over again? When I see square root of 2 over 2, I'm like, oh, that's -pi/4. And I always want to make x negative for some reason, but it's not in the fourth quadrant. So I hope we see that -pi/4 gives us negative square root of 2 over 2. So now we have secant of -pi/4. So once again, my recommendation is if you're doing secant of pi/4, it's going to be the same thing as cosine, but just a reciprocal of it. So you can think about it as 1 over cosine of -pi/4. And that would be 1 divided by square root of 2 over 2, which is just 1 times 2 over square root of 2. And then 2 squared over 2. Rationalize it. And you get square root of 2. So this one's a little bit more challenging, but I hope you see what I did. I looked here. I said, okay, I know secant is 1 over cosine, so I just wrote it in that way. I know what cosine of -pi/4 is, and then I felt comfortable dividing fractions. So that's going to be 15. We're almost done right here. All right, so this one is probably the hardest one on here. So there's a hint. The hint says since 3 over 4 is not on the unit circle, draw a right triangle. So if we look at this inside part, the question that is being asked is, what angle produces 3 over 4? But the issue with this is there's no angle that gives 3 over 4 on the unit circle. So we're going to draw a triangle, and we're going to ask ourselves, tangent is restricted to quadrant 1 and quadrant 4. Since it's 3 over 4 and it's positive, we know that we're in the first quadrant. This is theta. Tangent means opposite over adjacent. And if you do Pythagorean theorem, you should figure out that this is 5, or you should know that this is a 3, 4, 5 triangle. So the question is asking me, what angle gives me 3 over 4? And I know this is going to feel like cheating, but the answer to that, everybody, is just theta. You do not know what this is, and you can't find it out, but you don't actually need to find it out. All you need to say is, there is some angle that gives me 3/4. So now the question is, what is sine of theta? Well, sine means opposite over hypotenuse, so my answer is just 3/5. This is a really unique problem, but what really makes it stand out is whatever it says like arc tan or arc cosine or arc sine, the fraction will not be on the unit circle, so you should know to draw a triangle. So that leaves us right here. I think this is 16. Yep. All right, we got one more example like that. So for instance, 2/3, everybody. 2/3 not on the unit circle. Restrictions. Q1, Q2. Once again, the values are positive, so I know once again I'm in the first quadrant. This is theta. Cosine means adjacent over hypotenuse. But do you see how this time I don't know what this is? And this is not like a 3, 4, 5 triangle or one that's a little easier just to see. So what we're going to do on the side of our paper is just do Pythagorean theorem. So we're going to have A. So the most important part is that this part is C. And then 2 could be A or B. It doesn't matter. So 4 plus B squared equals 9. B squared equals 5. Square root of both sides. Erase this question mark. I did not mean to erase that side. And you get square root of 5. So once again, if we look at this, what angle gives me 2/3? Well, everybody, that angle is just theta. And then cotangent means x over y, or adjacent over opposite. So this is 2 over the square root of 5. Rationalize. And this is my final answer. And you know we did the circuit right because you see how we end right here. And if I zoom out real quick, every box should be filled. Thank you for staying with me for this long. I hope this helps. Keep practicing, keep grinding. Until the next time.